Welcome back to another video. Why did the fish keep getting bad grades? Because he was below sea level. Okay, let's get to it. Today we are talking about reflections in the X and Y axis, and this is nothing we haven't seen before. So all this stuff we kind of known, we're just putting a little bit of detail towards it. Okay, so for example, if we're talking about y equals 2 to the x, that's on the left-hand side, that is a exponential, goes up like that. And if I'm talking about y equals 2 to the negative x, it actually reflects. So it kind of like swaps over. Okay, I don't know if you can kind of see that. Now, what that gives us here is this is actually a reflection in the y-axis, which means the left-hand side kind of gets flipped over to the right-hand side, or the right gets flipped to the left. Okay, that's a reflection in the y-axis. And the way that we do that, as you can see from our little example, very simply is we've changed or replaced x with negative x. Okay, can you see that? All we've done is replaced what used to be a positive x. We've replaced it with a negative x. And that gives us a reflection in the y-axis. And that works for all functions, not just the exponential, but for all functions. Make sure that is written down. Okay. Now, we can reflect on the y-axis, but it also makes sense that we can reflect across the x-axis too, so from top to bottom. So we can see here two things that we're very familiar with, hopefully. Y equals x squared, parabola. And if I have y equals negative x squared, it's a negative parabola. And you can see that it's reflected in the x-axis, which means that we folded from the top, we switched it to the bottom. Okay, so we've kind of switched it that way. And all you can see that we've done here is we've just kind of made the whole thing negative. Now, the way that we would talk about it is we would talk about it like we would replace, if I can get the right color. What we've done here is we've replaced y with negative y. Okay. And so it's kind of like the x helps us find the y's and the y's helps us find the x, kind of like your intercepts. But in this case here, to reflect, if I replace x with negative x, that reflects across the y. If I change the y with negative y, I'm actually reflecting across the x. Okay, so again, let's highlight this bad boy, get this down. Okay, now moving on, there's one more, is we can also rotate 180 degrees about the origin, or as many degrees as we want really, but 180 is a common one. What I mean by that is there's your origin and we're going to reflect it 180 degrees. So I'm going to put a pin in it and spin it around 180 degrees. That's where my graph would end up. Now, if you can kind of see, if I was to draw another one, it's just kind of like, it means that I've reflected it twice. I've reflected it once across the y and then once more across the x. So how do we do this? In other words, we're just going to replace x with negative x. That will flip it across the y. And then once we're kind of now on this blue path, I just need to reflect it one more. How do I reflect across the y? Or how do I reflect across the x? Sorry, I replace y with minus y. And that's how we would rotate by 180 degrees. Okay, hopefully that's making a little bit of sense. Okay, now all these rules don't just apply with the graphs that we've shown, they work with any and all graphs. If you want to reflect a certain way, then you replace x with negative x. If you want to replace y with negative y, it's going to reflect it a certain way. Okay, that's the idea. Now, let's see what this actually looks like in question, in practice. They won't always give you some graph. Sometimes they'll give you a like an equation, other times they'll give you a graph. So here they've given us a graph and that's our function. And we want to change x into negative x. So in other words, this is a reflection across the, oh, if I can spell across. This is a reflection across the y-axis because we're changing the x to a negative x. In other words, it's going to look a little bit like this. Okay, so, oh, hold on. Let's not get too hasty here. Okay, it actually goes this way here. And then it goes this way. Yeah. That looks a bit better. If I was to reflect it and swap the left to the right, and again, I could tell you what this value is here. Instead of -1, that's now 1. I'm going to label that as 2. And that's going to be my reflection across the y. Okay, now for this one here, if I put it this way, can you see that I've just replaced the y with a -y, but I've multiplied or divided through by -1. So I make y my subject. This means that I'm reflecting. Let's use green. Why not? So this is a reflect across the x-axis. That's what that is. Okay. So to reflect it across the x-axis, that means the top becomes the bottom and the bottom becomes the top. So I can kind of see that it should look a little bit like let's see. It's going to look like this on this side. And it's going to look a little bit like that. Okay, and this point here should be -1, and this time instead of +2, it'll be -2. So you can see that it looks very similar to the graph above, but it's actually now shifted to below the x-axis. Okay. Hopefully there's no questions there. There's one more type that you'll need to know. What if we did it by they give you an equation instead? Okay, same rules apply. What happens if I reflect in y-axis? That means I change from x to -x. So in other words, this is a nice easy one. To reflect in the y-axis, it would just be y equals 3 to the power of, instead of +x, it would be -x. If I want to reflect in the y-axis, that's a fancy way to say that y now changes into -y. So mathematically, what that becomes is -y equals 3 to the x, or writing it as y equals, I just times both sides by -1. Okay, moving the negative to the other side. And the last one is if I rotate by 180 degrees, this is the one where x changes to -x and y changes to -y. So in this case here, to answer this one would just be -y equals to 3 to the -x. And rearranging to get y as the subject, I just times both sides by the -1. Now remembering, it doesn't affect the power, it just affects the number out front. That there is it. That's all you'll need to do, and work hard. See you guys later, and bye-bye.